would be G of 1 right here. Okay? That's what a integral represents. Okay? So G of 2, I should have done that in black, shouldn't I? All right, I'm going to do this one in G of black. G of 2 is, we're putting 2 in for x, so 0 to 2 of f of t. That's f of t. So 0 to 2 would look like, what, from here to here? Okay, it's all this. All right, G of 6 would be 0 to 6 of f of t. So that would be all of this and all of this. Okay, G of 6. Okay, so just literally do, put your x in, whatever it is, and then you know what you know about integrals, so don't let that mess you up. Okay, and we'll get back. Oh, sorry.
And you still just integral. Is there going to be, like later on, is there going to be a type of function where we're going to replace like an x and a y or something like that? Or two x's, like a top and bottom, so we're going to have like two numbers?
Yes, I think so, if I understand what you're asking me, yes. Okay, let's evaluate g of x. Okay, evaluate means to find the value of. Okay, now, there's a little line here, which means it's a little bit different than you here. How would we evaluate that definite integral? How do we evaluate any definite integrals? We don't have a graph, we don't. Okay, antiderivative, what is it? Right. You mean t to the third over 3?
Oh, I saw two in there.
Okay, all right. And then from 1 to x, right? Okay. So what does that equal? Okay. So that's the value of it. That's the best we can do if we don't know x. Okay. If we knew x, we'd join it. Okay. Now this is g of x. That's what we said it was. Let's find g prime. G prime. What is that? Now we're going to find the antiderivative, find the derivative. I know, it's x squared. Okay.
It's not the antiderivative, it's the derivative.
Right. But that is something that we got to clear up pretty quickly, is that you got to go back and forth. They are all constantly going back and forth. And now, do you recognize there's any, hey, if we just put this x in here, it'll be x squared, right? Okay. Just keep that in mind. There's no point in having this then, if that's all we're going to do to find g prime, right? Right. Okay. So, this is the fundamental theorem of calculus, which is probably the most important theorem in calculus, bigger than the EBT, bigger than the MBT. Those have been little big theorem. Fundamental, yes it is. Okay. Basically, it connects differential calculus and integral calculus. Okay? So, you've done this piece before. No, you haven't done this piece. This is the piece we just illustrated on the other page. If f is continuous on a closed interval, then big F of x equals the integral from a to x of f of t. As a derivative, it is f of x. Okay? Now, I know it's a lot of what does that even say? Okay. Basically, it says that every continuous function has a derivative, has an antiderivative, and the process of differentiation and antidifferentiation, which is the same as integration, right, are inverses of each other. Okay? So let's think about this. when we did this, if we know these are inverses of each other, a derivative and an integral are inverses of each other, and I want the derivative of an integral, then there's an easier way to do that than what we just did. So here we go. All right, this is the derivative of this integral. Don't forget that's what we're doing. Even though sometimes we forget the notation, d dx means I want to take a derivative of an integral. Okay? So what should I do? I should just throw this x in for the t, and I'm done. Okay? Because I'm going to take the antiderivative, and then I turn around and take the derivative. I'm right back where I started, except I want it in terms of x, this derivative, this variable right here. Okay? This can be any constant. Okay? It does not matter because it takes care of itself when you do the derivative anyway, as we just saw on that one on the first thing. Okay? So don't even worry about that. Just make sure it's a constant. Okay. Again, we're taking the derivative of an integral. What is it? 1 over 1 plus x squared. Okay? Now, this is the easiest thing you're going to do. But it's the first thing you're going to forget because it's so easy. All right, now, this one's a little bit more complex. Why? Because it's an x squared, so we're going to have to use the chain rule. Okay? The derivative of the integral is still this plugged in. Okay, so that's cosine of x squared, but then the derivative of x squared is done. Okay, that's a chain rule. 2x, I'm going to put that out front, cosine of x squared. Okay? So when you have something other than an x there or a single variable, you have to use the chain rule. Okay? All right, a little twist here. The constants of the top. Inverse it, negate it, yes. So we're going to negate and switch around from 3 to sine of x. Okay, now yes, then if this thing can go outside of the thing, outside of the integral or inside, I prefer it outside, then it's not in the way. But that's what happened when we switched around our two numbers here. All right, who wants to give me the derivative of that? Putting in this or this, right? So that's what? Cosine. So negative sine squared?
Yeah.
Okay.
You have to change the derivative of x on the chain rules.
Derivative of x.
Oh, sine of x.
Okay. And that's cosine of x. That's your answer. That's a chain rule. So we had to negate it because those were backwards numbers, and then we still had to use the chain rule there. Okay? So you want your upper limit to be just a variable, otherwise you have to use your chain rule. And your lower limit is a number, and it doesn't matter what number it is. Okay? What if they're both functions? Well, if we reverse them, we'll still have two functions. We're going to add, we are going to split it up. Okay, this is what I'm going to take. I'm going to split that integral into tangent of x to, give me a number, any number. Okay? And then I can start with that to squared. And that's the same integral, right? Just spread it out a little bit. Now that 4 can be anything, it doesn't matter. You don't even have to think, well, it's 4 in between tangent of x and x squared? Yes. Doesn't even matter. It will be. Okay. So, and these brackets are just remembering that we have the derivative. Don't forget that we're doing the derivative. This is where it gets kind of weird. All right. I guess we could do. Now, remember the derivative of a sum is the sum of derivatives. So now we're going to take this derivative. So let's find the derivative of that first interval. Do what? We need to negate it, don't we? So let's do, and then this would change to 4 in tangent of x. Okay. And then we're going to take the derivative of that. I'll just rewrite it. And this one's totally fine. The number needs to be at the bottom, a little more left. Okay. Here we go. What does this equal, Abby? Negative something. Putting this in to that.
1 over square root of 2 plus tangent x to the 4
So tangent 4x is how we write that. Okay.
times secant squared x.
Good job. Okay. You would probably clean that up, and it would look like this. Okay. Good job, Abby. All right. What about you, Fag? What about the second arrow?
1 equals x.
Plus x to the 8th. Yes, because you're taking x squared and taking it to the 4th. Times. Okay. Totally forgot that, didn't you? So what would that clean up to be? You already told me this is going to be 2 plus x to the 8th. 2x on the 8th. Okay, and just leave it. There's no point in doing anything more with that. Okay, so with the addition of your derivative of your integral, you can take the derivative of, you're going to have a lot of mixing up, so we got to get that whole derivative thing straight. And remember, we have hardly done any integration. Okay, we have kept it very simple. It's either, do you recognize it as being a common derivative? We have like the power rule that we can inverse pretty quickly, and that's it. So, it's very simple right now, but it's not going to always stay simple. Does anybody have a question on this big problem? I wrote out a lot that you probably wouldn't need to, but that's the final answer. Yep. It's ugly, but it works. Okay. Anybody? All right. All right. The part 2 of the fundamental theorem, we were using it. You just didn't even name it. Okay. You should recognize that. Again, F is continuous, and on every point on A and B has to be able to find the integration. And if big F is the antiderivative, then big F would be on the top minus big F of A on the bottom. Any definite interval of a continuous function can be calculated without taking minutes and without Riemann sums. Okay, so let's try a couple more. Now, let's try really hard not to use our calculator as far as Math 9 unless we're just checking, okay? Because you've got to get good at this, and if you don't practice, you're not going to. It's not going to happen. Okay, so give me an antiderivative, Lindsay Smith.
X cubed over 3 plus x.
Very good. Okay, from 0 to 3. All right, plug it in now, Rivers. Plug that in, Rivers.
And plus 3 minus 0.
Okay, which equals what, Sarah? Okay. Very good, very simple. Okay. Go ahead and try that one. When that negative kind of disappears, I'll give you a minute. And then we'll just check it in the calculator and hopefully we'll be good to go. Is that all right? No?
I did that.
Even like pulling out your calculator to do the math, you've got to really, because there's a lot of computation involved, you just got to get used to doing that. And then if you are bad at the computation, you'll get better. Hopefully. Right? There's, okay. The negative, remember, when you fourth something and when you take it to the second power, the negative is the last thing you do, so it still has to remain negative. Okay? Find a mistake?
Yeah, I just did not.
Which
Particularly me adding.
Okay. All right, so we've got some examples of what we're going to do with this function and what we're going to do with this derivative business. So we've got, and then I think I added some, yes, I added some AP problems. Okay, yay. All right, so again, g of x is this integral, just like when we started first page. Okay, f is the function whose graph is shown. So I'm going to write f over here just so I remember, okay, f, because f and g are different, okay? Sometimes they're interchangeable, but now they're not. What is this also besides f? Say it again, Allie. It's g prime. So I'm going to write g prime too. Because if I take g prime, look what happens. G prime throws this in here, and it's f of x. Okay? So that's, you got to be careful. It gets a little weird. Okay? At what values of x do the local max, here we go, that has something to do with, and minimum values of g occur? Okay, so remind me again, chapter 4. Where do you find the local max? Okay, let's say local max of g, just to be clear. Where will they happen, you think? You mean g prime? Okay. Okay, good job. Okay, and the local min of g will be when g prime changes from negative to positive. Okay? Now, I don't know, if you didn't know that theorem, that theory, I don't know how you'd go about solving it. Okay, so this is g prime. So where does g prime change from positive to negative? At 2. Okay, right there, went from positive to negative. All right, anywhere else? 6, positive to negative, good. Anywhere else? No. Okay, where is the local min's going to go? From negative to positive, g prime changes. So 4, it says negative to positive, and 8, negative to positive. Okay, very good. Okay. So this was key to the problem, understanding that that is the same thing as f in this case. Okay, on what intervals is concave? Is G concave down? What do we want to know about G? G is concave down when G. Yeah, I don't want to talk about G prime. I want to talk about G double prime is negative. Yeah, I don't really like. Oh gosh, I don't really like increasing and decreasing, but if that works for you,
It's just the same thing.
I know. It makes me crazy. But if it works for you, go ahead and use it. Okay. I'm just not going to be using it. Okay. And where do we? This is G prime. How do I get G double prime off of that? What am I going to be looking at? G prime on the graph are going to be what? G double prime on the graph is going to be, I'm going to be looking at what? The slopes. Okay. And they're going to be plus or minus. That's all they're going to be. Okay, so G double prime, I'm going red here. G double prime. That's the slope of this. What kind of slope do I have it like right at this moment? Positive, still positive, 0. Then I go negative, negative, negative. I keep going, negative, negative, 0. Then I go positive, 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 0. Negative, 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 0. Positive, positive, 0, negative, negative. Okay, those are G prime in red. Okay, so concave downward, we're talking intervals now. Panic.
From 1 to 3, and then also X.
G concave 1 to 3, she said, and 5 to 7. 1 to 3, positive.
Oh, and then also it would be 9 to infinity, I guess.
Negative.
Yeah.
We're looking for negative, right? Sorry. 1 to 3,
So,
5 to 7,
and then 9 to
9 to 10.
either 10.
Yeah, I don't say that. I don't say that. I get that's. We're gonna stop at 10. Okay, good job. Okay, so be careful, be clear. You're talking about G, you're talking about F, and it will get a little nutty for you, but just keep working at it. All right, concave upward. All right. We kind of already did this new function. What do I want to do? Concave up. Why is concave up? When? What do I know? You pick. Y double prime is positive. Okay. So tell me what Y prime is, Molly.
Well,
You put that in.
yeah.
Okay. And tell me what Y double prime is then, Allie Rivers.
3x.
Okay. And we've done that a million times, right? How do we find where this is? Well, maybe quite a million. Okay, how do I find out where that's positive? Set it equal to 0. You gotta start with 0 before we can do positive or negative. So 3x squared equals 1. X squared equals. So x equals. X. Negative 1/3 radical, positive 1/3 radical. All right, so y prime up here is positive, and then remember that's a quadratic. If your 3 is positive, it's going to open up. So technically it goes like this. The y prime is. So that's how we did that so quickly. So concave up is where? Good. Okay. And no, you don't want to simplify those. We stopped doing that last year. It's the end, right?
No.
Or we didn't. Okay. we did this year, yeah. And it doesn't even matter what those numbers are. Okay? I mean, 1/3 the waste of your time. Okay? All right, very good. Okay, let's try, here's a multiple choice, 23, that means it's calculator driven. So go ahead and, what that is. I don't know that calculator's going to be very helpful, but.
Is that TQ?
Yes. This is x squared. I don't know why it's not very clear. It always looks clear until it gets up here. X cubed, the integral, and then t, sine is t cubed.
Are you just saying first one now?
Yes, let's do the first one. Okay, which is it? E. You take and put your x squared in for cubed, you get a 6, and then times 2x squared. Okay, those are very simple, but again, it'll be, because we haven't had to think about it, I mean, one of the first things we forget. Okay, let's try this. It's really, this one's kind of tricky. Sorry. Okay, rate of change of the altitude of a hot air balloon is given by RT. Rate of change for 0 to 8 seconds. Which of the following expressions, this would be non-calculator, gives the change in altitude, this is what we talked about today, of the balloon during the time the altitude is decreasing. Yeah. This would be not calculator. Wait, 82. Oh, the first part's no calculator. You can use the calculator on that, sorry. Let's go through it. First of all, what does this represent? What does that represent? We're in words. This is what we did. Distance.
Area.
Okay, let's use the words that make sense to this balloon problem here. I'm not doing any area. We're not doing change in what? Altitude. Okay? So that's the change in altitude. Does that help you? Okay, so all of these are, this would be appropriate for those, and then those are R prime. Okay? D and A as interesting choice. You had the numbers, but you didn't know whether it's R prime. That's totally okay, but I really think that's probably, as long as you have the numbers, let's see where the numbers come from. So this is the change in altitude. When the altitude is decreasing, what do we know about the derivative of this is what? The derivative of that is decreasing. Did we go there? Okay, so if you graph this, did everybody graph that? I hope. What does that look like? Because you've had the calculator. Let's see. T to the third minus. Gosh sakes.
You have the pen. Yeah.
Nice. Go away. Need more random dots here. Clear. All right, I don't know what my thing looks like. We're going from 0 to 8, so make sure 8 is included. I'm just going to do 0 to 8, and I don't know if that other will work, but let's check it out here. No. Okay. Okay. I usually, when I'm doing this, I usually will start out with the standard window and then work with that. So it's honestly decent method. Okay. So remember that 0 to 8. Does it come back down? Okay. So then you found these roots, I'm assuming, and that was the where you got the 1.572 and the 3.514 here. And if you look at this now, this interval that's from this piece right here is decreasing. Can you tell me why that is all negative? Yes. If you understand that this is the change in altitude, okay, then we want the change in altitude. So that's why we're going to put A instead of D, because this is the change in altitude. Okay, remember this is already a rate of change, so that's why we put it in here and not take the derivative of it. So that's a key point, is to see that. Okay, good job. All right, that one was kind of tricky. All right, let G be the function given by G of x. That's from the integral from 0 to x of sine of x squared, t squared dt for x between -1 and 3. On which of the following intervals is G decreasing? Okay. This is calculator, yes. Don't forget you have a calculator. You can totally. Okay. Got an answer?
Yes.
Is it A? No. Is it B?
No.
Is it C?
No.
Is it D?
Yes.
Oh, you're so smart. Okay. So G is decreasing when G prime is what? Negative. So here's G prime. Okay. And then what did you do to get? The answer was D. What did you do next? Plugged it with this?
Yes.
So you put that in here? You did the graph? Okay. Sine of x squared. All right. Oh, wow.
Yeah.
Yeah.
We just need negative. It's just not gonna work with it does.
No, you press your on button and stop your dressing. Yeah. Yeah.
I do secondly.
-1, 2, 3.
And negative.
Okay.
Actually, it's actually not. That can be simple.
Yeah. Especially when you have that derivative and it takes forever and you're like, I don't want that, because you have to wait for the whole thing. Okay. So again, what are we looking for? Decreasing. G prime is negative. So you're talking about this little guy right here? Yep. Okay. Awesome. Good job. All right, I'm done. You are so smart.
Okay, it's so much. Just having years.